Hello students, today we are going to see about inverse Z transform in signals and system. This is the problem. X of Z is equal to 2 by 1 plus Z inverse into 1 minus Z inverse the whole square. So we need to apply the partial fraction for the given problem. Before applying the partial fraction, first we need to convert all the inverse Z terms into normal Z terms. So first we have to convert the inverse Z terms and all into positive power Z. So 2 by 1 plus Z inverse I can write as 1 by Z into again 1 minus Z inverse I can write it as 1 by Z the whole square. So just simplify this term. So which is equal to 2 by, so here we can take LCM as Z. So 1 into Z it is Z plus 1 and then into again for this term the LCM it is Z. So 1 into Z it is Z, Z minus 1 the whole square, which is nothing but 2 by, so Z plus 1 we can write as it is divided by Z, and for this term we have square for both numerator and denominator, so which we can split it as Z minus 1 the whole square divided by Z square. So both the terms we have both numerator and denominator in the overall denominator term. So which is equal to 2 by, so when we take reciprocal this term remains in the denominator, so this term will go to the numerator. So Z will go to the numerator, so 2 into Z into again Z square divided by Z plus 1 into Z minus 1 the whole square. So this is the overall term in the right hand side. So left hand side we have X of Z. So we can easily apply now the partial fraction for this term. Before applying the partial fraction we have to take one Z to the left hand side. So X of Z divided by Z. So for this term only we need to apply the partial fraction too. So take one Z to the left hand side. So what are the remaining terms in the numerator? It is 2 into Z square because we have taken Z to the left hand side divided by denominator it is Z plus 1 into Z minus 1 the whole square. So for this term we can apply the partial fraction. So what are the terms? A by Z plus 1. So coming to the second term in the denominator it is repeated roots, multiple roots are there. So Z minus 1 the whole square. So we have to write this as, first write Z minus 1 because we have Z minus 1 into Z minus 1. So first we have to, for the repeated roots first we have to take the power as 1, which is nothing but Z minus 1. Then C by Z minus 1 the whole square. Second we have to take Z minus 1 the whole square. For example, if we have the terms like 2 by Z cube, so we have to take it as A by Z, B by Z square. We have to increase the power and write the next term, and then C by Z cube. So like this we have to split. So using that we can write Z minus 1 the whole square as B by Z minus 1 and then plus C by Z minus 1 the whole square. Then what are all the terms we have in the left hand side? So we have to compare this and this. So what is the numerator in the left hand side? Just write in the left hand side. So we have 2Z square. So 2Z square alone we can write in the left hand side. Then A. So coming to the denominator term here, just compare this term. Here it is Z plus 1, here it is Z plus 1 into Z minus 1 the whole square. So Z plus 1 already it is available. So which is not there, Z minus 1 the whole square only it is not there. So this term we have to multiply with A. So A into Z minus 1 the whole square plus B into, again compare this Z minus 1 into denominator here. So Z minus 1 already it is there. Another Z minus 1 it is there and Z plus 1 it is there, which we have to multiply with B. So B into Z plus 1. So already Z minus 1 is available. So leave one Z minus 1. Another Z minus 1 will be there. So just multiply with that. And then plus C. So compare this term with the denominator. Here also Z minus 1 the whole square. Here also Z minus 1 the whole square. So leave this term. Only we have to multiply with Z plus 1. So Z plus 1 we have to multiply with C. So now we have to find out what are all the A, B, C. So for that we have to substitute the value of Z such that each and every term get cancelled. So what are all the terms we can substitute? So when we observe this term it is Z minus 1. So z minus 1, when it will become 0, when we substitute 1, z equal to 1, 1 minus 1 will get cancelled, so that this term will get cancelled. So one of the term it is z equal to 1 and another term it is z plus 1. Z plus 1 when it get cancelled, when we substitute z equal to minus 1, minus 1 plus 1 will become 0. So I can substitute another term it as z equal to minus 1. So other terms I don't know. So first let us find out these two terms. So another substitution, if it is not there, if you want you can just take z equal to 0 or any other value also you can substitute and find out the other term. So first let us find out the a term, right, that is this term, that is when we substitute z equal to 1, whichever the term we can find out, that we can find out first. So substitute z equal to 1. So here in the left hand side 2 into 1 square, which is equal to, here when we substitute 1, 1 minus 1 get cancelled, so this term get cancelled. So this term get cancelled. So similarly when we substitute z equal to 1, this term also get cancelled. So we will get only c term. Okay, so only we will get c term. So here it is c into z value it is 1, 1 plus 1. So anyway 1 square it is 1, 1 into 2 it is 2, which is equal to c into 1 plus 1 it is 2. So c is equal to 2 by 2, c is equal to 2 by 2, which is nothing but 1. So c value it is 1. So similarly let us substitute other two values. So substitute z equal to minus 1. Here in the left hand side it is 2 into z square, so minus 1 the whole square, which is equal to, when we substitute minus 1, this term remains the same, but when we substitute z equal to minus 1, minus 1 plus 1 will become 0. So this term will get 0, and similarly minus 1 plus 1 will become 0, so this term will become 0. Only a term will be available for the second substitution. So a into z equal to minus 1, minus 1 the whole square, another minus 1 is also there, so minus 1 the whole square. So 2 into minus 1 the whole square, minus 1 the whole square is minus 1 into minus 1. So minus into minus plus, 1 into 1 it is 1. So minus 1 the whole square it is 1, which is equal to a into minus 1 minus 1, it is nothing but minus 2 the whole square. So 2 into 1 it is 2, a it is equal to, again the same thing, minus 2 the whole square means minus 2 into minus 2. So minus into minus plus, 2 into 2 it is 4. So which is a into 4, a into 4. So which is nothing but a value, it is given by a, it is equal to 2 by 4. So let us apply 2 table, 2 ones are 2, 2 twos are 4, which is nothing but a equal to 1 by 2. So a it is equal to 1 by 2. So in order to find out the b term, we need to substitute z equal to 0. So let us consider the equation, the overall equation, and substitute z equal to 0. So left hand side when we substitute z equal to 0, here it is 2 into 0 square, which is equal to a into, we have z minus 1 the whole square. So here it is 0, 0 minus 1 it is minus 1 the whole square, plus b into 0 plus 1 it is 1, and then 0 minus 1 it is minus 1, and then plus c into 0 plus 1 it is plus 1, which is equal to, so 0 square it is 0, 0 into any value it is 0. So left hand side it is 0, a into minus 1 the whole square. So minus 1 the whole square, it is minus 1 into minus 1, which is plus 1, plus b into 1 into minus 1 it is minus 1, plus c into 0 plus 1 it is 1. And we have determined already the values, a is equal to 1 by 2, c is equal to 1. So such value we can substitute here. 0 is equal to a value it is 1 by 2, 1 by 2 into 1, plus b value I don't know, so b into minus 1, plus c value it is 1, 1 into 1. So 0, 1 by 2 into 1 it is 1 by 2, and then minus 1 into b it is nothing but minus b, plus 1 into 1 it is 1. So we have the terms like 0 is equal to 1 by 2 minus b plus 1. So this minus b we can take to the left hand side. Why? Because we are going to find out b value only. So take that term to the left hand side. Minus b will become plus b. When minus b goes to the left hand side, it become plus b, which is equal to, what are all the remaining terms? 1 by 2 plus 1, which is equal to, so 1 by 2 plus 1 it is nothing but a 3 by 2. So take LCM if you want. So common LCM it is 2. 2 into 1 it is 2, 2 plus 1 it is 3. So 3 by 2. So which is nothing but B is equal to 3 by 2. So once we have determined all the three values, just substitute in the expression. So what is the expression we have? X of z by z is equal to a by z plus 1, b by z minus 1 plus c by z minus 1 the whole square. So substitute all the three values in those equation. So we have x of z by z which is equal to a by z plus 1 plus b by z minus 1 plus c by z minus 1 the whole square. So x of z by z is equal to a value we have determined it as 1 by 2, 1 by 2 divided by z plus 1. B value we have determined it as 3 by 2, 3 by 2 divided by z minus 1. C value we have determined it as 1, 1 by z minus 1 the whole square. So just take now z to the right hand side. X of z is equal to 1 by 2 into z by z plus 1 plus 3 by 2 into z by z minus 1 plus z by z minus 1 the whole square. So we know that inverse z inverse of z by z minus 1, it is nothing but 1 power n u of n. 1 power n it is nothing but 1. So it is just u of n. Similarly, z inverse of z by z plus 1, it is minus 1 the whole power n u of n. Why? Because the common thing it is z by z plus a. A means if it is plus a, we have tried it as minus a the whole power n. If it is minus a, we have tried a power n u of n. So since it is z plus 1, we have tried it as minus 1 the whole power n u of n. And then we have another formula such that z inverse of z by z minus 1 the whole square, which is nothing but n into u of n, n into u of n. So all these formulas we have to know. Using this we can just find out the inverse z transform of the given expression. So when we take inverse z transform in both the sides, x of z will become x of n, which is equal to 1 by 2 z inverse of z by z minus 1. So z inverse of z by z plus 1. Similarly, plus 3 by 2 z inverse of z by z minus 1 plus z inverse of z by z minus 1 the whole square. So which is nothing but x of n is equal to 1 by 2. So for this we know that minus 1 the whole power n u of n, minus 1 the whole power n u of n plus 3 by 2. For z inverse of z by z minus 1, it is u of n, 3 by 2 u of n plus z inverse of z by z minus 1 the whole square, it is n u of n, n u of n. So this is the final answer for the given problem. Thank you. Thanks for watching.